which is the second part of discussing Venn diagrams. The learning targets for this are going to be calculating probability with Venn diagrams and matching probabilities from Venn diagrams. We're also going to start to see what's called conditional probability. So that's the probability of A given B, and we're going to see how do we calculate a probability given a restriction or a condition that's already happened. In these examples, you're going to see they're going to look a little different than the previous section. The previous section we were listing different values or elements that fell within an event. Now we're going to kind of switch it up a bit and look at data collected from different scenarios, and the values that are in there are representing the quantities from those different categories that we created with that data. So for example, this example 1 says students in 6th-hour lunch were polled on if they have a job or play a sport, and there's a Venn diagram that's being created for that. So just to kind of identify what these values actually mean, they're identifying that event A right here. Event A is defined as students having a job. And so what that means is there's 100 students who have a job. There's 75 students who have a job but also fall within the condition of event B, which is being in a sport as well. And then so anything within that yellow circle is going to represent someone who identified as having a job. In the green circle I created, that's event B. So what that means is you have 200 students who identified as being in a sport, and then 75 students also identified as being in a sport, but they kind of fell within both categories. So they identify as having a job as well as being involved in a sport. One thing that's also a little different is we have this idea of 25, this 25 that's just kind of hanging out here. And so what that means is there's 25 people that were involved in like the poll that's falling within the scenario, but they didn't identify as falling within either category. So they didn't have a job, they didn't have a sport, maybe there's something else, if there was something a third. So a lot of times when there's a rectangle that falls outside of this Venn diagram and there's a value, what that means is there's a quantity that we need to represent that didn't fall within either event or category we set up. Okay. The rest of it is very similar to what we saw in the previous you saw in the previous video. So we have we always like to identify the number that's involved in our sample or our sample size. So we're going to go ahead and add that up. So we have 100, 75, 200, 25. If I was to go ahead and add all 4 of these values up, we would get 400. So what that means is there are 400 students that are represented in this data. The first question says, what is the probability that a student has a job? So again, a job, that's our event. That's our event A. That's right here. And so that would be 175 because you put the 100 and the 75 together. So there's 175 students who identify as having a job because I added the 100 and the 75 out of 400. And then when I divide that, that would be my probability of 0.438. So probability is calculated the same way that we saw in the previous video. For the probability that a student has a job or plays a sport, again, this is really, so this first one was looking at the probability of A, essentially. The second one is looking at the probability of A or B. Or it's really like saying the union, right? It can fall into A or B. So we know we're taking this out of 400 because that's out of the entire amount. And we're looking at the number of students that fell within either circle. So they fell within the 100, the 75, and the 200. So if we add these three values up, or a lot of other ways that you can kind of get to this value, it would end up adding up to 375. And if I divided it out, we would get a 0.938. Right, so basically what that means is 93.8% of the students had a job or were in a sport. Okay, so if I wanted to turn into a percent, you just multiply by 100. The part C says that what is the probability that a student has a job and plays a sport? So this is basically like writing the intersection, right? So what's the probability of A and the intersection of B, right? So that's looking at what's the probability that it falls within both of those circles, and that would simply just be this 75 right here. So we would write 75 over 400 and then divide it out. So that would be 0.188 or 18.8%. The last two, part D and E, again, using the same data, right? So we still have N is 400. And it starts to get a little bit trickier here. So this next one says, what is the probability a student has a job given they play a sport, right? So what's happening is it's creating a condition, right? So we're looking at, of the students who play sports, how many of them have a job? And what's the probability that a student who plays a sport also has a job? So this is the same if I knew that this was event A and event B. This is the probability um, of what is the probability that a student has a job given they are also in a sport, right? So the condition is they have to be in a sport first. And usually like there's kind of keywords in here like the given that. So lots of different ways that you can kind of calculate this out. Probably the easiest way to probably do it is we're going to look at, well, of the students who play a sport, well, let's see how many kids are actually in that pool. So the total possible we're taking out of not 400, but of the students who play a sport. So that'd be 75 and 270 and 200, so we get 275. And of these kids who play a sport, how many of them have a job? And 75 have a job. And so if I do 75 over 275, I get 0.273 or 27.3%. Okay? So again, the condition here is we're taking it out of the number of kids who play a sport because they need to have that condition that's in there. For part E, it's same thing. It says what's the probability a student does not have a job? So it's kind of, again, switching it up a little bit. So the probability a job was event A, so it's like the probability of not A. I'm gonna put a little bar on top. Notice though there's no other condition, right? So it's not saying given that or if that or anything like that. So we're still taking it out of the full amount, unlike the previous one that had some sort of condition. We're just looking out of these entire 400 kids, how many do not have a job? So when we talk about not having a job, we can do this a couple different ways, but basically um, we're, um, we're not counting anything that falls within having a job. So we're like using the 200, but this time we're also using that 25. So there's 25 people that don't have a job as well. So when we add that up, we get 225. And that would be 0.563 or 56.3%. And that would be it. In this next example, we're going to be matching Venn diagrams. This is similar to a question you can see on like a test or a quiz. And so the big idea here is you're going to be looking at these different Venn diagrams and seeing which of these match the characteristics that are listed on the left-hand side. So the first one is asking for what's the largest sample size. So which one contains the basically the greatest amount of data, right? So if we add up the values, which one would give us the largest n value? So when we go ahead and add these up, you can see the first one, 3, 5, 2, and 1. That would give us an n of 11. 4, 1, 1, and 2. That would give us a sample size of 8. 2, 3, 1, and 4 would give us a sample size of 10. 8, 2, 8, and 10 would give us a sample size of 28. And the last one would be 2, 3, 2, and 7, which would give us a sample size of 14. So the one with the largest n value would be the letter D, which of 28, and so that's what would match with number 1. So for this one, next question, we're still working with the same problem, so we can actually we know what the sample size for all of these are. We can cross out letter D because we know we're not going to use it again. And now we're going to see which one has an inner probability where A and B, the probability is 0.3. So this is the intersection. So when we calculate it, we're still using our sample size as our denominator. So we end up having... so for the first one, we have 11 on the bottom, 5 at the top. So 5 11ths would be 0.45. This next one, the denominator would be 8. The numerator would be 6. So that's 0.75. For the next one, again, our intersection, the value we have is 3 over 10, and that would be 0.3. And that happens to be the one we're trying to match. So for number 2, you'd have a letter C, because that's the Venn diagram that has the probability of A and B is 0.3. For question 3, again, we're still using the same matching, so we can cross out C and D. We know we're not going to use them again. And we're looking this time now for the union. So we're still going to use all of the same sample sizes as before. The big difference is it's A or B, so we're going to use any values that are listed within the Venn diagram, within the circle. So for the first one, if we add this up, we're going to get 10 over 11, which is going to be 0.91. The next one we're going to have is 4, 1, and 1, so 6. So 6 over 8, which is 0.75. And then for E, we're going to have 2, 3, and 2. So that's 7 over 14, which is 0.5. And that's going to be our answer for letter E. For this last, number 4 and 5, we're down to choice A or choice B, so I crossed the other ones out. And the first one is probability of A given B. So again, under the condition of B, an easy way to do that is the value on the bottom is going to be how many elements fall within B. So if we look at for all of these, or for the first one, the number of elements in B would be 7. And the intersection of the two circles is 5. So this first one would be 5 over 7, which would be 0.71. And then just to kind of check to make sure, or actually no, we actually would have then A would pair with number 4. That's what we're looking for. For number 5, we can check just to be on the safe side. So we're looking for conditional that B given A. So if we wanted to check to make sure we were right, A has 5 in there, and then that would be 1 over 5, or 0.2. If you have questions from this video, feel free to sign up